Brief description. Description of Msdac Alcatel MIG. This is a digital axle counter equipment for multiple track sections, which counts the axles and decides the track occupancy status of a track section. The word AZLM used hereafter to denote the equipment. It consists of several detection points referred as rail contacts connected to a central processing unit known as axle counter evaluator. ACE, which decides the occupancy status of several track sections. Conventions. Reference count direction RCD. The reference count direction RCD is defined for the entire layout independent of the direction of train movement. The use of RCD ensures that the correct order of counting into and out of a section is maintained throughout a series of detection points. Without the RCD, the system cannot be correctly configured. When a train passes detection point number 1 in the direction of the RCD or detection point number 2 in the opposite direction to the RCD, axles are counted into the track section ATS1 and axles are counted out of the track section ATS1 when a train passes detection point number 1 in the opposite direction of RCD or detection point number 2 in the direction of RCD. The rail contact, which is first passed by an axle in the axle counter reference count direction, is defined as rail contact 1 or SK1, and correspondingly the second one should be rail contact 2 or SK2. Design features. AZLM is designed for use as a train detection system in station section and block section. Its ACE, that is Axle Counter Central Evaluator, can supervise 36 detection points with 24 track sections with full complement of cards. Refer topic deciding the size of ACE in subpara 7.8 for details. One detection point can be assigned to a maximum of 4 track sections. The maximum length of track section is limited by the power supply to the detection point and the data communication from the detection point to the ACE. System architecture. The AZLM, consisting double rail contact SK30H, that is mounted on rail, and an electronic unit EAK30H, which is contained in the trackside housing, is positioned at each end of the track section to be supervised. The axle counter evaluator, that is ACE, evaluates the data from the EAK30H at each end of the associated track section and determines whether the track section is occupied or clear by counting axles in or out of each track section. Track section controlling relays are operated by the ACE to indicate section occupied and section clear. The train detection interface between the interlocking, that is solid state or relay interlocking system, and the ACE may be provided by relay contacts or Ethernet interface in case of SSI. ACE is equipped with diagnostic interface software. An RS-232 serial interface provides communication to a computer. The main parts of the system are given below. Outdoor equipments, that is detection point EZP30H. It consists of double rail contact, that is SK30H. Electronic control unit, that is EAK30H. Indoor equipments. It consists of ACE, that is Axle Counter Central Evaluator. Vital relay. Reset box, that is ERBM02. Power data coupling unit, that is PDCU. Power supply for ACE and EZP30H. Outdoor equipments, double rail contact, that is SK30H. Description. Its main parts are transmitter head, receiver head, Protective hose. Fixing parts for hose. The SK30H consists of two transmitter heads, that is TX, installed on the outer side of the rail and two receiver heads, that is RX, installed on the inner side of the rail directly opposite to the respective transmitter heads. The rail contact is electrically insulated from the rail. The transmitter head contains the transmitter coil. The casing of the receiver head is made of aluminum alloy. It contains the receiver coil. Installation. Selection of installation point on rail. The rail contact is mounted on the rail as shown in figure between two sleepers. Any embossments on the rail web must be removed. On double track lines, the rail contact should be mounted preferably on the outside rail. Rail contact has to be installed at a distance not less than 1 to 2 meters from a rail joint, that is fish-plated or welded or insulating joint. Rail contact has to be installed at a distance of greater than or equal to 2 meters from the adjacent rail contact of same type, that is SK30H, in order to avoid mutual interference. The operator must ensure that other equipment used or installed at the track does not influence the correct functioning of the detection points EZP30H of AZLM, example, detection points of other manufacturers. Step 1. Rail mounting holes are to be drilled in the correct position as shown in the figure to ensure reliable working of the system. Where A is equal to height of the rail contact, mounting holes from the base of the rail. H is equal to height of the rail, which depends upon the rail profile. B is equal to the diameter of the hole. B is equal to 13 millimeters plus or minus 0.2 millimeters. C is equal to inter-separation distance between the holes. C is equal to 148 millimeters plus or minus 0.2 millimeters. The following approximation formula can be used for calculating the height of the holes on the rail web from the base of the rail. A is equal to 0.409 into H plus 1.5 in millimeters. Following table gives an indicative example of the height of the rail contact mounting holes as per various rail profiles. For 90-pound rail profile, the height of the center of the holes from the bottom of the rail is 56 millimeters. For 52 kilogram rail, its value is 63 millimeters, and for 60 kilogram rail, its value is 68 millimeters. Step 2. The three holes of diameter 13 millimeters are to be made on the rail web. For this purpose, use of drilling jig, which is shown in the figure, is recommended. The drilling jig consists of drilling template, mounting device for the drilling machine, templates for the standard rail profiles, fastening device, drilling machine. Optionally, drilling machine may be made available from ELDYNE. Step 3. The rail contact is mounted on the rail with transmitter heads on the outside and the receiver heads on the inside of the rail. The 3M12 bolts must be tightened to 45 Newton meters by means of an adjustable torque wrench supplied only with a toolkit ETU 001. Each transmitter head is mounted on an aluminum casting with 2M8 bolts. It is important that the teeth and the grooves of the aluminum casting and the transmitter head are correctly lined up. The 4M8 bolts must be tightened to 25 Newton meters by means of an adjustable torque wrench supplied only with the toolkit ETU 001. Note: after tightening the nuts, the bolts should protrude a minimum of 2 millimeters. If it is less than 2 millimeters, the transmitter head and the aluminum casting must be rechecked for correct fitting. Nylon bushes are inserted into the holes of the brackets for the protective hose to insulate it from the rails. Mark the rail contact integral cables before putting them inside the protective hose as SK1 or SK2 according to reference count direction, so that after taking out from the other end of the protective hose, those cables can be identified easily. The protective hose must be cut to the correct length before the cable is inserted. The hose must be made watertight with a rubber seal on the rail contact side and the hose clamp on the side of the EAK. The length of the protecting hose must be adequate to ensure that the necessary support for the cable at the heads is provided. Exposed integral cables of rail contact at the transmitter and receiver side should have adequate radius of curvature so as to avoid stress on the cable. Measure should be taken that this exposed part of the cable does not touch the sharp edge of the ballast. The integral cables of the rail contact are available with 3 different lengths: 4 meters, 5.5 meters and 8 meters. Choosing the right length of integral cable is very important before installation. The cable should not be shortened. Deflector plates are to be installed to protect the rail contacts from hanging metal objects from passing train. Deflector plates should be placed at a distance not less than 25 centimeters from the track device. Outdoor equipments, trackside electronic unit, that is EAK30H. Housing of EAK30H. EAKs are housed in a mushroom cover as shown in the figure. Made as per IP, that is ingress protection, 55 specifications, near the track device that it controls. If it is provided inside a location box, then it is provided with a dust cover. Parts of EAK30H. EAK30H mainly consists of analog board, evaluator or digital board, cable to transmitter 1, receiver 1, transmitter 2, receiver 2, motherboard, diagnostic interface of toolkit, that is ETU001, connection to ACE and power supply. Analog card. Its main features are generation of 24-volt supply for working of EAK, generation of 30 kHz and 28.6 kHz signals for the transmitter coils, amplification of the signal received from the receiver, to demodulate the phase modulated signal and to rectify it, generation of analog wheel pulse, that is Msdac, generation of digital wheel pulse, that is RADEMP. Digital card. Its main features are wheel counting, decodes incrementing or decrementing counts as per RCD, supervises rail contacts, codes telegrams, that is data packets, transmits data to ACE via ISDN protocol for evaluation. Dip switch. 2 pairs of two-way dip switch sets are provided on the motherboard of EAK30H. These are used for addressing of each detection point, that is EZP30H. Power supply of EAK30H. The power supply for EAK30H can be taken either using a separate battery bank IPS module or by using a DC-DC converter module connected at the feed end of ACE. The following power supplies are associated with EAK30H. 120-volt DC supply using AC-DC or DC-DC converters as per the supply arrangement. Its range is between 116 volt to 124 volt DC. 110-volt DC supply using AC-DC or DC-DC converters as per the supply arrangement. Its range is between 108 volt to 112 volt DC. 100-volt DC supply using AC-DC or DC-DC converters as per the supply arrangement. Its range is between 97 volt to 103 volt DC. 60-volt DC supply using AC-DC or DC-DC converters as per the supply arrangement. Its range is between 58 volt to 62 volt DC. 60-volt DC supply using battery. Its range is between 54 volt to 72 volt DC. 24-volt DC supply using AC-DC or DC-DC converters or battery as per the supply arrangement. Its range is between 21.5 volt to 27.6 volt DC. 12-volt DC supply using AC-DC or DC-DC converters or battery as per the supply arrangement. Its range is between 10.8 volt to 13.8 volt DC. Power consumption of EAK30H using the above supply voltages is 7 watts only. Installation of EAK30H. Identify the location for mounting the mushroom cover or the location box where the EAK is to be installed. Identify the route for laying the integral cable in a protective hose from EAK to rail contact. EAK30H can be connected to the SK30H using different cable lengths 4 meters, 5.5 meters and 8 meters. The cable shall not be shortened or joined. If found in excess, then it can be kept coiled. Connections with rail contact. SK30H is connected to the EAK30H using 0.2 by 24 twisted shielded cable. Each transmitter and receiver heads are connected to EAK30H using separate cable. The SK30H is connected to the terminals of the electronic unit as per the table below. Separate terminals are provided on EAK for connecting transmitter and receiver cables from SK1 and SK2. Transmitter cables from SK1 having colors black and transparent are connected to S1 and S2 terminals of EAK respectively. Receiver cables from SK1 having colors black and transparent are connected to E1 and E2 terminals of EAK respectively. Whereas blue-colored cable is connected to E3 of EAK for grounding purpose. Same color coding is used for connecting transmitter and receiver cables of SK2 to EAK. Connection to ACE and power supply. Each EZP30H is connected via a 2-wire ISDN link to the ACE. If power and data are transmitted over same pair of cable using PDCU, then connection is made as follows. Terminal 3 is positive power and data cable. Terminal 13 is negative power and data cable. Terminal number 1 and 2 and 11 and 12 are required to be looped. If power and data are transferred over separate pairs of cable, then the following connections method is adopted. Terminal 1 is positive power. Terminal 11 is negative power. Terminal 3 is data line. Terminal 13 is data line. Terminal 2 and 12 is not required to be looped. If the same EAK is used for monitoring two different track sections, then terminal 4 and 14 is used for the second ISDN link. Indoor equipments, power data coupling unit, that is PDCU. PDCU is used between outdoor equipment, that is detection point, and indoor equipment, that is ACE. One PDCU is used for one EZP30H only. The PDCU enables usage of same pair of conductors for data transmission from detection point to evaluator and power supply to detection points from evaluator by superimposition. Terminal numbers 1 and 2 are used for connection to positive and negative power supply respectively. Terminal number 3 is used for grounding purpose. Terminal numbers 4 and 5 are connected to terminal numbers 3 and 13 of EAK30H. Terminal numbers 14 and 15 are connected to terminal numbers 9 and 10 or 11 and 12 of the serial card of ACE. Terminal numbers 7 and 8 are connected to terminal numbers 1 and 2 of next PDCU for carrying the power supply. Terminal number 6 is connected to terminal number 3 of next PDCU, which is used for grounding purpose. It also isolates the ACE from EZP30H in case of any short circuit. For this purpose, a 315 mA fuse along with fuse blown off indicator is provided inside PDCU. In some applications where local power supply is used to feed the EAK, the superimposed power and data is not used, in which case the PDCU will be used for isolation of communication line and only connector number 4, 5 and 14-15 are used. PDCUs are to be installed on 35 mm DIN rail. Indoor equipments, axle counter central evaluator, that is ACE. ACE is of two types. 2 out of 2 having 10, 26 or 42 input-output slots. 2 out of 3 having 32 input-output slots. In 2 out of 3 system, any 2 out of the 3 CPUs are used. Maximum ambient temperature of the ACE rack shall not exceed 55 degrees. The product name of an ACE is composed as follows. ACE X/YY. YY is number of input-output slots. X is 2 or 3 CPU. Example, ACE 2/26 means 2 out of 2 system with 26 input-output slots configuration. Both serial and parallel input-output can be plugged into standardized input-output slots. Power supply and CPU cards are fixed in predefined slots as shown in the picture. One power supply card occupies 1 slot and one CPU card occupies 2 slot positions. It comprises of the following cards. Serial cards, parallel cards, power supply cards, CPU cards, serial card. It receives the information from the detection point and provides this information to the CPU card. One serial card can monitor up to a maximum of 2 detection points. It occupies one input-output slot in the ACE subrack. The serial input-output interface consists of 2 independent ISDN links. Serial card LED indications. LEDs for channel 1 and 2 remains lit if ISDN links are intact. LEDs for channel 1 blinks when a telegram is received from ISDN 1 link. LEDs for channel 2 blinks when a telegram is received from ISDN 2 link. Serial card connection method. Each input-output slot is having a 12-pin WAGO terminal block. Depending upon the type of input-output card, the WAGO terminals are connected. Terminal number 9, 10 is used for connecting one EZP30H. Terminal number 11, 12 is used for connecting second EZP30H. Terminal numbers 5, 6, and 7, 8 are to be shorted in order to avoid crosstalk between both the ISDN links. For each detection point, one pair of ISDN link is used. Parallel card. For each track section, one parallel card is required. Section clear or occupied condition is proved via parallel card. It receives instruction from the CPU and gives section clear or occupied information through potential free contact of relay located inside it. Reset command of a section is given through the parallel card. A parallel card can be configured for either preparatory reset, for which 1 and 2 WAGO terminals are used, conditional hard reset, for which 3 and 4 WAGO terminals are used, LED indication of parallel card. First row green LEDs for channel 1 and 2 will lit when external input 1 is activated. Second row green LEDs for channel 1 and 2 will lit when external input 2 is activated. Third row green LEDs for channel 1 and 2 will lit when the vital relay picks up. Fourth row yellow LED for channel 1 will lit when non-vital output 1 is activated. Fourth row yellow LED for channel 2 will lit when non-vital output 2 is activated. Fifth row yellow LEDs will lit to indicate polling between the CPUs. Sixth row green LEDs will lit indicating don't care condition. Parallel card connection method. Terminal 1, 2 is used for vital input 1. This is used for preparatory reset. Terminal 3, 4 is used for vital input 2. This is used for conditional hard reset. Terminal 5, 6 is used for giving reset acknowledgement indication. Terminal 7, 8 is used for giving any user-defined technical fault indication. Terminal 9 is used for plus 24 volt DC for driving the vital relay. Terminal 10 is used for R1 of vital relay. Terminal 11 is connected to R2 of vital relay. Terminal 12 is connected to minus 24 volt DC. Power supply cards. Two numbers of power supply cards are required. One power supply card is used for each CPU. Input supply to the power supply card is 24 volt DC. It generates 5 volt and 12 volt DC for system functioning. LED indication of power supply card. All three LEDs will remain on during normal operation. When LED number 2 is off, it indicates overload or undervoltage at output 1. When LED number 3 is off, it indicates overload or undervoltage at output 2. When both LED number 2 and 3 are off, it indicates that either input voltage is too low or too high. When all three LEDs remain off, it indicates that input voltage is not available. CPU cards. It is the decision-making unit. It works on 2 out of 2 logic, that is, 2 CPU cards are required for working of the system. If any one of the CPU card becomes faulty, then the complete ACE will become dysfunctional. Whatever vital information is being received by the ACE, it will be processed by both the CPUs independently. Then the CPUs will perform a voting procedure to determine if the results tally or not. If not, a safety reaction is performed. The CPU cards have alphanumeric display which show a rotating bar if the CPU is operational. It has a diagnostic software. Using the diagnostic software, complete system's health monitoring can be done. It has a serial RS-232 port and Ethernet port which enable it to be interfaced with computer for diagnostic purpose. For CPU 1, RS-232 port is used for data downloading purpose, and for CPU 2, Ethernet port is used. For interfacing with another ACE, this Ethernet port can be used. CPU 1 and 2 cards are identical and interchangeable. It has a reset button, which is used for resetting the CPUs. LED indication of CPU card. Flashing of LED number 1 indicates communication on Ethernet interface. Flashing of LED number 2 and 3 indicates that the communication between both the CPUs is available. Normally, both the LEDs keep on flashing. LED number 4 is not used. For details about Ethernet connection, refer to the link provided at the end of this subtopic 7.8. Main functions of CPU are evaluation of the data from the detection point, vital track occupancy information output, vital reset input, non-vital output, diagnosis using diagnostic software, self-test, deciding the size of ACE. ACE2/10 has two numbers of CPUs with 10 input-output slots and one subrack. ACE2/26 has two numbers of CPUs with 26 input-output slots and two subracks. ACE2/42 has two numbers of CPUs with 42 input-output slots and three subracks. ACE3/32 has three numbers of CPUs in which one redundant with 32 input-output slots and three subracks. Supply voltages used for ACE2/10, ACE2/26 and ACE2/42 are 60 volt, 48 volt or 24 volt DC, whereas supply voltages used for ACE3/32 are 60 volt or 48 volt DC. The range of these voltages are plus 20% and minus 10% of the rated supply. Power consumption of ACE depends upon types and number of input-output slots. Maximum power consumption of ACE2/10, ACE2/26, ACE2/42 and ACE3/32 are 55 watts, 95 watts, 135 watts and 125 watts respectively. Selection of proper configuration of ACE. Since a serial card or a parallel card occupy one slot in ACE subrack, trade-off between number of track sections vis-a-vis detection points is required as shown in the example below. In a typical station with 24 track sections require 24 parallel cards. If 42 input-output system is used, then 42 minus 24, which is equal to 18 slots, are available for serial cards. As each serial cards can supervise two detection points, above system can serve 18 into 2, which is equal to 36 detection points. An overview or summary of working of MSDAC. When a wheel passes over track device TD1, a phase reversal of the receiver signal will take place in the track device, which will be sensed by the EAK1. This information will be provided to the serial card of ACE via PDCU. One serial card can monitor two detection points. The serial card will transfer this information to CPU 1 and 2 cards parallelly. Both CPU 1 and 2 cards will process this data and will tally with each other and will give the information about the section occupied to parallel card controlling the particular track section. The parallel card in turn will cut the feed going to the coil of the vital relay. As a result, the vital relay will drop and section occupied red LED indication will appear. Similarly, when the train goes out of the track section from TD2, it will be sensed by the EAK2 and the same information will be given to the serial card of ACE. Both the CPUs will process and tally the data and will give command to the parallel card to drive the vital relay. The parallel card in turn will provide feed to the vital relay and a section clear green LED indication will appear. Data programming of CPU card in the ACE. Following steps are followed before installation of AEZ-LM starts. Naming of detection points and their positions. Naming of track sections. Determination of RCD, that is reference count direction. Next step is the configuration of ACE. The main features of ACE hardware configuration are cable networking. Computer redundance is 2 out of 2 or 2 out of 3. Interface to solid-state interlocking, that is serial cards. Number of serial input-output and parallel input-output cards. Cabinet or rack. Power and data coupling. Cabling in relay room. Earthing. It is prepared based upon the following data. Names of the track sections supervised by ACE. Addresses of the detection points. Sections associated with the detection points. Delay time for track clear. Non-vital output on the parallel input-output card. Installation of ACE. The following connections are to be made during installation of ACE. Power supply to ACE. Connection to the detection point. Connection of relays. Power supply to ACE. U1 and U2 are the connectors for 24-volt DC supply to ACE. Polarity of the supply should be checked before connection. Connection to the detection point. The slots slot 1 to slot 10 are used for input-output cards, either serial or parallel depending upon the site-specific software. If the second subtract is used to convert an ACE 2/10 to an ACE 2/26, a flat cable with FRC connector of 10 pins is to be connected from C1 connector of the first subrack to the C1 connector of the second subrack. Each input-output slot has 12-pin Wago strip connectors numbered from X1 to X12 on the backplane of the subrack. If a serial card is plugged into an input-output slot, say slot 1, connectors X1/9 and X1/10 are used for communicating ISDN with the detection point. Connections from X1/9 and X1/10 go to pin 14 and pin 15 respectively of the PDCU, that is connection with the concerned detection point. Connectors X1/11 and X1/12 of the same input-output slot are used for communicating with another detection point. Connections from X1/11 and X1/12 go to pin 14 and pin 15 respectively of another PDCU, that is in connection with a concerned detection point. Connectors X1/5 and X1/6, X1/7 and X1/8 should be made short with a small looping wire to avoid crosstalk between two ISDN communication signal coming from two detection points connected with the same serial input-output card. The pin assignments for a parallel card plugged in, say slot 10, are given below. Connectors X10/1 and X10/2 are used for providing vital input 1 for preparatory reset. Connectors X10/3 and X10/4 are used for providing vital input 2 for conditional hard reset. Connectors X10/5 and X10/6 are used for providing non-vital output 1 for reset acceptance. Connectors X10/7 and X10/8 are used for providing non-vital output 2 for any technical defect. Both the non-vital outputs give 4-second pulse through optocoupler for the conditions defined in site-specific software. Pull-up voltages are required to use these outputs in electronic circuits. Connectors X10/9, X10/10, X10/11 and X10/12 give the vital relay output through the potential free contact of two relays provided on the parallel card. Indoor equipments, vital relay. It is the vital track section, that is ATS, controlling relay. It is a 24-volt DC 8F by 8B QN1 relay. The CPU gives the command for driving the vital relay via parallel card. Connection diagram of vital relay with parallel card. 24-volt DC power supply for driving the vital relay is connected between 9 and 12 terminals of parallel card via a 500 milliamperes fuse. The vital relay coil is connected between 10 and 11 terminals of parallel card. Two different relays are controlled by two different CPUs and both are supervised by each other. When both relays are picked up, then only the vital relay connected externally to the parallel card is picked up. A free-wheeling diode, that is 1N4007, should be connected across the vital relay coil. This will help to protect the parallel card from higher voltage generated across the relay coil during the change of position of relay. The contacts of external vital relay QN18F by 8B can be connected to interlocking as per requirement. Reset box, that is ERBM02. In Indian Railway, two types of resetting methods are adopted. Preparatory reset, conditional hard reset. ERBM02 is the reset box for Alcatel's multi-sectional digital axle counters, that is AZLM. It provides the basic resetting pulse, that is 24-volt DC to ACE, to reset a particular section. AZLM reset pulse should be in the range of 0.5 seconds to 6 seconds. The front panel of the terminal consists of push button, reset counter, preparatory reset indication green LED, line verification indication yellow LED, section clear or unoccupied indication green LED, section closed or occupied indication red LED. The SM's key module for multi-section reset panel consists of reset key, power on LED indication, that is yellow LED. This reset key acts as the common key for all the reset boxes used in particular installation. Additionally, a buzzer is provided to give audio indication that the 3-second reset pulse is on. Following steps are to be followed to initiate a reset. The SM inserts the key, turns it clockwise and then pushes. If optional cooperative reset key is provided, this has also to be turned simultaneously by another authorized person. For this, H and R to be shorted at selection jumper J1 on PCB. If the cooperation or line verification is not required, then P and R are to be shorted. While key is in turned position, the reset push button for a specific section is pressed momentarily. Buzzer sounds for 3 seconds and then stops. The key is then turned back anti-clockwise and taken out. A reset operation is only possible when section is occupied or disturbed. When reset is initiated for a straight line section that is assigned for preparatory reset in the site-specific software and the system accepts the reset, ERBM02 front panel indicates that the system is under reset state by means of the preparatory reset, that is green LED. The section occupied, that is red LED, also glows indicating that the system is waiting for a train movement through the section. With the passage of a train through the section with equal count in and out of greater than 1 axles, the system commands the vital relay to pick up. Contacts of this vital relay change the status of the occupied, that is red LED, to off, and clear, that is green LED, to on, indicating that the section is now clear. The reset on LED also goes off, indicating reset is successfully completed. If the section is a point zone that is assigned for conditional hard reset in the site-specific software, the vital relay picks up immediately after commanding the reset provided there is no technical defect in the system. Each reset is registered in the sealed reset counter unit. The counter increases by 1 after each reset commanded by the operator. Each train now moving into the section is indicated by the occupied, that is red LED. A complete passage of a train out of the section is indicated by the clear, that is green LED. ERBM02 is very compact yet extremely rugged. It is simple to install and operate. The unit is housed in heavy sheet metal with scratch-proof powder coated finish. Wedged mounting base gives the front panel comfortable view and ease of operation for the operator. The detachable top cover is locked at the rear and makes ERBM02 tamper-proof, yet accessible only to authorized service personnel if required. The field cables have their entry from the back through the cable gland and are terminated at cage clamp type Wago terminals. Only serviceable parts inside ERBM02 2500 mA slow blow glass cartridge fuses. For communication between ACE and EZP30H, only quad cable is to be used. 2-wire ANSI T1.60 one communication protocol with ISDN modulation is used. Maximum characteristic cable capacitance allowed is 45 nanofarad per kilometer for 0.9 mm diameter quad cable and 50 nanofarad per kilometer for 1.4 diameter quad cable. Higher value of characteristic capacitance may reduce the specific transmission length. For better reliability, the correct pair of star quad cable, that is diameter 0.9 mm IRS TC30/96 should be used with a proper termination. Insulation resistance of quad cable used shall be more than or equal to 10 mega ohms. The communication characteristics of the installed cable must be guaranteed by the installation contractor. For details, refer to topic 11, that is reference material. Maximum communication distance allowed between ACE and EZP30H. When separate power and data cable is used, the maximum attenuation permitted for the ISDN link is 24 decibel. A 0.9 mm quad cable causes 2.6 decibel per kilometer attenuation and 1.4 mm quad cable causes 2 decibel per kilometer attenuation. Note: 1 PDCU causes 3 decibel attenuation. Based upon these factors, the maximum length of communication cable can be ascertained. Some examples are given in the following table, showing maximum communication distance. By using 0.9 mm diameter cable and without any PDCU, maximum length of communication between ACE and EAK is 9.23 kilometers. Whereas with 1 PDCU, the maximum length reduces to 8.07 kilometers. By using 1.4 mm diameter cable and without any PDCU, maximum length of communication between ACE and EAK is 12 kilometers. Whereas with 1 PDCU, the maximum length reduces to 10.5 kilometers. When both power and data are transferred over the same pair of cable, it depends upon the type of cable used, loop resistance of the cable, and maximum cable resistance permitted. Table showing various types of cables used for power supply to EAK and their loop resistance. Table showing various supply voltages and maximum cable resistance permitted. Now, taking the reference of the above two tables, let us calculate the maximum communication distance for the following examples. Example 1. Let the supply voltage is 100 volt DC, that is maximum permitted cable resistance is 240 ohms. And if 0.9 millimeters cable, that is loop resistance, is 55 ohms per kilometer is used for the superimposed circuit, then the maximum length of communication between ACE and EAK is equal to 240 divided by 55, which is 4.36 kilometers. Example 2. 60 volt DC supply taken from battery bank is used, that is maximum permitted cable resistance is 28 ohms. Now in this case, if we use 0.9 millimeters quad cable, that is loop resistance 55 ohms per kilometer, then maximum communication distance will be equal to 28 divided by 55, which is 500 meters only. So, in order to increase the communication distance, separate power cable as specified in the table should be used. If we use 2.5 square millimeter stranded cable, that is loop resistance is 15 ohms per kilometer, then the maximum length of power supply cable is equal to 28 divided by 15, which is 1.86 kilometers. Cable used between SK30H and EAK30H. 0.2 by 24 twisted 2-core screened copper cable is used, which is to be intended along with EZP30H. Different lengths of cables are available, that is 4 meters, 5.5 meters and 8 meters. All are having different specifications. The length of cable is decided depending upon the distance between rail contact and EAK. The cable shall not be shortened or joined. If found in excess, it shall be kept coiled. All 4 numbers of rail contact cables to be connected at WAGO terminals of EAK30H after proper twisting of TX and RX cables. Connection diagram of EAK, PDCU, serial card and parallel card in a 2DP single section configuration. Earthing. Earthing of ACE cabinet. ACE cabinet to be earthed with 25 square millimeters copper cable along with lug. Earth resistance should be less than 1 ohm. Earthing of EAK30H. EAK has to be connected to the earth return rail with a copper cable of 25 square millimeters or an iron cable of minimum 50 square millimeters. If earth return rail is not available, then housing has to be earthed to a suitable low inductance, that is lesser than 40 microhenry, and low resistance, that is lesser than 4 ohms. Earthing of quad cable. It shall be less than 1 ohm. Earthing of mushroom cover. Mushroom or dust cover to be earthed with 25 square millimeters copper cable along with lug. Its earth resistance should be less than 1 ohm. Earthing of the screens of all 4 numbers of rail contact cables. First, the installation of all 4 numbers rail contact cables are to be removed up to a length of approximately 45 millimeters and the screens to be connected to the earthing bar of EAK by using the clips supplied with the equipment. For details, refer to topic 11, that is reference material. LED indications of EAK. LEDs are provided on the analog and evaluator or digital cards to indicate different status of the system. Different LED indications are shown in the following table for analog card. H1 one red LED normally remains off when there is no wheel on SK1. When there is a wheel on SK1, this LED lights. H1 2 green LED normally keeps flashing, indicating that no wheel is approaching SK1. That is, mess up 1 is within tolerance limit. It goes off when a wheel approaches SK1. H2 one red LED normally remains off when there is no wheel on SK2. When there is a wheel on SK2, this LED lights. H2 2 green LED normally keeps flashing, indicating that no wheel is approaching SK2. That is, mess up 2 is within tolerance limit. It goes off when a wheel approaches SK2. H3 one red LED remains off when 24 volt DC required for card functioning is within tolerance limit. It lights when this voltage goes out of tolerance. H3 2 green LED remains on when 5 volt DC is available. It goes off when this voltage is not available. H1 2 green LED normally keeps flashing, indicating that no wheel is approaching SK1. That is, mess up 1 is within tolerance limit. It goes off when a wheel approaches SK1. H1 one red LED normally remains off when there is no wheel on SK1. When there is a wheel on SK1, this LED lights. H2 2 green LED normally keeps flashing, indicating that no wheel is approaching SK2. That is, mess up 2 is within tolerance limit. It goes off when a wheel approaches SK2. H2 one red LED normally remains off when there is no wheel on SK2. When there is a wheel on SK2, this LED lights. Different LED indications are shown in the following table for evaluator or digital card during system operation. H1 one green LED normally keeps on flashing while transmitting data. H1 2 green LED normally remains off. It lights when CPU 1 indicates a fault during self-test of analog part. H2 1 green LED normally keeps on flashing while transmitting data. H2 2 green LED normally remains off. It lights when CPU 2 indicates a fault during self-test of analog part. Limitations. Point-to-point address setting needs to be done. Longer length of communication cable is required for connection of outdoor equipments with central evaluator.